Alright guys, welcome to Thompson Coding Series. In the series, we'll be talking about ASP.NET Core in the .NET platform. So let's deep dive into it and see what it is about. So in this series, we'll be talking about the basic fundamentals you need to understand or you need to know if you are going to be developing application using ASP.NET Core framework. And we will start from the basic knowledge to the internals, ASP.NET Core internals, and evaluate how you can use ASP.NET Core to build web applications or build internet-related applications. So the very first thing I want us to consider in this series is what we mean by client-server analogy. So what does a client-server analogy is? We have considered this details in the Web Development Fundamentals series. If you've not listened to it, I will admonish you go ahead and listen to the Web Development Fundamentals series. It's actually a free series. Just go in there and get some vital information about Web Development Fundamentals, and that will aid your understanding what ASP.NET Core is actually about. So let's have a bird's eye overview of what client-server analogy is actually. So typically you have, we have this representation in our daily experiences. So we have, for instance, now we have a web server, and we have network, the internet network, and you have a whole bunch of devices that are connected to the internet to establish a connection to the server, for instance, to perform some form of task or operation over the internet. And we have clients which consist of laptops, mobile devices, desktop, different types of applications, or IoT applications running as clients, and these applications usually connect to a server over the internet or some form of a network. And we have servers, so applications on our phone or mobile devices or whatever instrument we're using or device we're using to connect to the internet will usually connect to the server to perform some kind of task. And this is what we consider typically as a client-server communication flow. So utilizing a network to connect two systems together for exchange of information is actually what the client-server analogy represents. And in some cases, predominantly most cases, on the server aspect, you can have a server, a web server, and the web server can connect to a database server. And in this case, the database server would serve like a server, and the web server would serve as a client. So the web server issues a request or some form of information from the database server, and the database server generates a response and sends it back to the web server. Now, this example is a typical analogy of what we also call client server. And this can be software to software, as the case may be, or machine to machine. When we say software to software, we mean that you can have both the web server and the database server reside on a particular machine. And you can have the web server software talk to the database software, or it can be machine to machine by having the servers installed on different machines and have them communicate with each other. So that is basically what the client-server analogy is, and it's vital for us to understand this while delving into deeper understanding or trying to understand what ASP.NET Core is actually about. So another thing that I thought that is necessary for you to understand in the series is what I typically call HTTP traffic flow. Now, you have clients as usual, and usually the clients could be your browser, which is a user agent that is performing some sort of request on behalf of the user. And the browsers typically issue a request, and the request passes through what we call proxies. And what are proxies? Proxies are typically systems or machines or softwares that relay HTTP messages between a user agent and a server. And that message is relayed to a typical server. And the server issues a response by saving some form of document or resource as requested by the client, and it passes through the proxy again back to the client. So proxies actually do HTTP message relay, and servers act as systems that provide resources for clients that want to access them. So typically this is what we mean by the HTTP traffic flow. Now in more detail, most times you raise a request. For instance, you type www.google.com and you issue a request from your browser, which is a user agent, to a server, and the server comes back with a response and handles the request and serves a response. And when the server handling the request and generating a response completes the entire request pipeline or request chain. So in predominant scenarios, there are a lot of entities we call proxies, which I've already explained to you, and the function they play. So proxies can act as gateways or caches. So basically a cache is a system on the network that could do many things, all right? Can function as a gateway and can also function as generate responses or store HTTP responses temporarily, and can use that response to resolve requests instead of hitting the server. So basically proxies are very vital in the entire communication channel or communication flow that we are talking or considering when we are talking about ASP.NET Core or any of the web servers or any of the web development frameworks we consider. Fundamentally, if you listen to the web development fundamentals, we made mention of back-end technologies, and we term them as server technologies. And what role do these back-end or server technologies play? So we have web servers which can connect to a back-end. We have web servers which acts as a resource access engine or resource control engine for applications. And we did talk about deep details about what roles web server play in a client server analogy. And typically we made mention of web application development languages such as JavaScript, Python, Ruby, Java, PHP, C#, PL, Golang, C++, Scala, and Kotlin. So these are the programming languages out there that you can develop web applications with. So a web application is a software program stored on a web server that utilizes web browsers and web technology to perform tasks over a network. So basically, these servers we have here run web applications. So we create a web application, you bundle them and put them on a server, and the server runs the web application. Predominantly, web applications are basically or mostly built using web frameworks. So a web framework is a set of resources and tools that support in the development of a web application. Now, there are some web frameworks out there that are affiliated to all these programming languages we've listed on the screen. So for instance, we have this bunch of frameworks for developing web applications. There are many more, but I'm just showing an example of them. So we have Laravel, which is a PHP framework. We have Express, which is a web framework for JavaScript on top of Node.js. We have Flask, which is a framework for developing Python web-based application. We have Ruby on Rails. We have ASP.NET Core, which we are actually considering in the series. We have Spring and we have Django. Django is also a web framework for Python. Spring is a web framework. Spring contains a framework or a web framework for Java and other cloud-related applications as well. Typically, you have a runtime on the machine that hosts your web servers, and the runtime provides the execution environment required for your web application to execute or to function properly. And typically you have example of runtimes are Node.js, which is a JavaScript runtime for server-based JavaScript applications. We have .NET Core for ASP.NET applications. You have the JRE, Java Runtime Environment for Java-based applications. So these are many more are the key concepts you need to understand when we're talking about web applications. Now let's move on to what is the crux of this particular series. This series, we are considering developing web applications, what it means, what you require to understand when developing applications in ASP.NET Core. So the programming language, though for the predominant programming language in the .NET platform is C#, though there's provision for support for Visual Basic and F#, but the most widely used programming language in the .NET platform is C#, and we are going to consider that. And the web framework we are talking about in this case, which is the subject of the series, is the ASP.NET Core. And basically, the server runtime environment for executing ASP.NET for providing an environment for ASP.NET Core based application is the .NET Core. It's the .NET environment, not just .NET Core. Apologies for that, because the .NET actually removed. It's just a platform now, and the word .NET Core is obsolete. It's just .NET. And actually, you could ask what .NET is. .NET means Network-Enabled Technologies, and that is what basically it is about. So the next thing we need to understand is the various classification of web applications. And typically, I categorize web applications as follows. One, as a server-based web API, also known as a REST API or RESTful API. And the next one is a server-side render user interface web application. And finally, a client-side rendered user interface web application, also known as front-end application. Now, if you listen to web development, to my series on the web development fundamentals, you will have a good grasp of what these various type of applications are and what functions or how they are architected or developed or structured to function. It gives you a better overview of what they mean. Now, let's talk about the main thing, the ASP.NET Core, which is ASP.NET actually represents active server pages, network-enabled technologies. And what is ASP.NET? ASP.NET is basically a web development framework. And according to Microsoft's documentation, it is a cross-platform, high-performance, open-source framework for building modern cloud-enabled internet-connected applications. So that is what ASP.NET is. So basically, you can build server-based applications and services, Internet of Things applications, and backend applications for mobile devices using ASP.NET Core. And we can build APIs and web UIs using this technology as well. So ASP.NET Core integrates seamlessly with popular client frameworks and libraries such as Blazor, Angular, React, Vue, Bootstrap, and a whole bunch of technologies or front-end technologies out there. Let's understand how ASP.NET is and how it is being hosted. Hosted means how we mount it on the server. Remember, there is a web server, and ASP.NET is just a web application you put on the web server, all right? And how does that happen? So let's talk about ASP.NET Core hosting. So ASP.NET Core is basically a console application in its natural form. It is a console application that's wired to handle and respond to web requests. It must be started when the server boots and restarted if it crashes. Now, a process manager is required to automate a start and restart in case of system shutdown. And the common process managers are Nginx and Apache for Linux platforms. And we have IIS, Kestrel, and under Windows Service for Windows platform. By default, ASP.NET Core project templates use Kestrel when not hosted on IIS. And that is very fundamental for you to understand. So you can ask Dominic, what is Kestrel? Kestrel, as I earlier mentioned, is just basically a web server. That is what it is. And you have your ASP.NET Core application. You have the application code, which contains the different components of your application you've crafted out. And you have Kestrel. So Kestrel uses the HTTP context object to interact with your application code, and you use the internet. From the internet, you can access Kestrel using the Hypertext Transfer Protocol (HTTP), as I earlier illustrated in the HTTP typical traffic flow. So in this case, Kestrel is used as an edge internet facing web server. So you can see that there is no proxy in this analogy. But so let's consider an analogy where we can have proxies and Kestrel sits behind proxies. Now you have Kestrel can be used with a reverse proxy such as Nginx, Apache, or IIS. So a reverse proxy server, it receives HTTP requests from the network on the internet and forwards them to Kestrel. Remember the HTTP traffic flow I showed you earlier? That is what we're talking about in this case. Now, typically you will have Kestrel sit behind a reverse proxy, which can be IIS or Apache or Nginx as the case may be, and you have interaction, a request response analogy between Kestrel and the reverse proxy, and you can have users connect over the internet to the reverse proxy you set up for your application. So this is a typical analogy when you are using Kestrel with a reverse proxy, and this is how the setup is being represented. So you can have an idea how to host a ASP.NET application now. So you can have HTTP connections directly to your Kestrel, or you can have them configured in a reverse proxy using IIS or Apache to allow users to communicate with your application. So basically, this is what ASP.NET hosting. This is how you can host your ASP.NET application, and it's vital for you to understand. Now, let us consider something more granular about ASP.NET Core. Now, what are the possible applications you can build using or under ASP.NET Core Web Framework? The very first application I want you to understand is you can build RESTful application. REST actually represents a representational state transfer, and these are services that allow other applications to connect to your application, and you can exchange some form of state. State means data, all right? You can exchange data in some specified formats of data. So ASP.NET gives support to the development of web APIs, and APIs, like I earlier mentioned, is application programming interfaces. So you can build web APIs and web applications using ASP.NET Core. So your web apps, you can build server-side web UI, and server-side web UI is an application that is every process, every response is generated on the server and just sent for the browser to paint, to display. And you can build MVC, model view controller. It's an architectural pattern. You can build MVC applications using ASP.NET Core. You can build client-side web UI applications. You can build remote procedure call you can build real-time applications using ASP.NET Core. ASP.NET Core supports the development of RESTful, like I earlier said, representational state transfer services using either the minimal API or the ASP.NET Core MVC. And in addition, ASP.NET Core supports the development of server-side rendered applications using the following project templates or technologies. You can build server-side rendered applications using ASP.NET Core Razor pages and ASP.NET Core MVC. So as I earlier said, MVC represents the model view controller architectural pattern, and it's a predominantly widely used architectural pattern when developing web applications. So ASP.NET also supports the development of client-side rendered applications using Blazor and prominent JavaScript frameworks and libraries like React, Vue, and Angular. So that is basically, you can do a whole bunch of internet-dependent applications out there using ASP.NET Core technology. And what are the internals? It's vital for us to understand how ASP.NET Core functions. What happens within ASP.NET Core? It's vital. How do you bootstrap an application? What are the pipelines required to handle a request? And that is vital for us to understand. So let's find out how the internals actually are. So basically, ASP.NET Core is actually a framework that sits behind Kestrel. And the very first object, when a request lands on your server, the request is sent, Kestrel gets the request and creates a HTTP context object that encapsulates this request, and it sends that to your application code. Now, so the HTTP context encapsulates all the HTTP specific information about a single HTTP request. When a HTTP request arrives at the server processes the request and builds a HTTP context object. This object represents the request which your application code can use to create the necessary response. And doing that, your application code is mostly bundled with middleware components which specify the pipeline for processing a request. And basically what we'll be doing is we're going to be writing instructions here in ASP.NET Core. So you have a request and land in Kestrel wraps up a HTTP context object, and you use the HTTP context objects to perform necessary operations or logic to handle whatever endpoint there is that the user actually initiates communication with. So the HTTP context object constructed by the Kestrel server acts as a container for a single request. It stores the request and response information such as the properties of the request related services, and any data to and from the request or errors if there are any. So for you to actually understand ASP.NET Core application, it is vital for you to recognize what we actually call the HTTP context object, because it forms the lifecycle, it represents the lifecycle of every request that lands on your server. So middlewares in an application code can access their HTTP context through their HTTP context accessible interface. That is just for you to know and remember. That's why I'm putting that details out there for you to see. So it's vital. From the analogy on the screen, from the representation, you have your request land on Kestrel. Kestrel creates a HTTP context object and hands it over to your application code. Your application code passes the HTTP context object through a set of middleware components which are specified in your request pipeline, and generates a response and pushes it back to Kestrel, which saves that to the user agent. Understanding this fundamental concept, not just in ASP.NET Core, is vital to you understanding how web applications actually function, or how you build and deploy web applications. So we have this. Let's analyze the HTTP context object and understand what it does basically. Now, the HTTP context object encapsulates all the HTTP specific information about a single HTTP request. So when you enter your browser and you hit a request, google.com or whatever request you issue from your user agent, which is actually your browser, when it gets to Kestrel, the Kestrel engine will actually craft out or create a HTTP context object that represents that request, that represents that request. And you have these properties. So when we say properties and we say object, you should understand that typically this is actually a class, and the class has properties. So the HTTP context object is actually a class, a blueprint for creating the HTTP context object itself. And this class has properties. So in that, we have the most vital properties, which is the HTTP request itself, and which represents an incoming side of the request. We have the HTTP response, which represents the outgoing side of the request, which is actually the response. And we have a session, which talks about is an object that manages user data, say user session data or user data session for the request. And we have the user that is associated with this request, which is the user for the request. So you have this and many more properties. So I just needed you to understand that HTTP context has properties, and because they have properties, they also have methods, and we have extension methods built into ASP.NET Core automatically by the .NET Platform managing teams. And we have typical extension methods like authenticate async, which validates user access credentials. We have sign in async, which signs in a user into our application. We have sign out async, which signs out the user, and a whole bunch of extension methods that are actually built into or that support the HTTP context object. And this typically is what a summary of most of the properties and extension methods we have that are associated with the HTTP context object. Now, we could relate this to a typical request where we have a request from your browser. For instance, you got to your browser and you issued a request for codingseries.thompsondominic.com, and which is actually a GET request. And you can see we have the authority, the domain you're using for the request. You have the method, which is a GET, and it has a path. All these are defined in the HTTP request object you'll find here on the screen. And let's deep dive and see what this is actually about. Okay, so let's consider internals, more of the internals, which are the middlewares. And basically, with this, we need to understand this before we get to the request object. Sorry for that. And let me talk about it. So typically, we now know that when a request comes into your server, the Kestrel server actually generates or builds or instantiates a new HTTP context object, which then is handed over to your application code. All right, and the HTTP context object has these definitions in them, and you have passed this information is passed in your application code to the request pipeline, and the request pipeline utilizes what we typically call middlewares. Now, you would say, Dominic, what are middlewares? Just in a moment, you'll understand what middlewares are. So you pass that object and you have a request passed into, for instance, you have middleware 1, middleware 2, middleware 3, and it gets to the last middleware, and the middlewares generate responses and send them back. It means it sends back the HTTP context object back to Kestrel, which actually contains a response, and it actually sends it to the server. Sends it to the user agent that initiated or originated this request. So basically, what is a middleware? So a middleware is a type of computer software that provides services to software applications beyond those available from the operating system. And that is according to Wikipedia. But according to Microsoft documentation, a middleware is a software that's assembled into an application pipeline to handle requests and responses. That is very straightforward. So basically, it's an application we hook into the application pipeline to handle a particular request and generate a response for that. And each component can choose whether to pass the request to the next component in the pipeline, and can also choose to perform work before and after the next component in the pipeline. So in ASP.NET Core, we utilize what we call request delegates to build the request pipeline, and the request delegates handle each HTTP request. So that is basically what happens when we are building our own custom applications in ASP.NET Core. And middlewares are not terminologies associated to only ASP.NET Core. They are associated to a whole bunch of frameworks out there, including Python frameworks like Flask, and JavaScript frameworks like Express that runs on Node.js. And these are very vital terminologies you should understand in developing or when you're developing web applications. Let's come back to the request analogy and evaluate what we were trying to say before. So typically your user agent's request is translated to an object in ASP.NET Core, and specifically the HTTP request object, which is a property of the HTTP context object. Don't forget that. And you have your system or device or an app running on your system. It generates a request like this, and the request hits Kestrel. Kestrel generates a HTTP context object, which has the HTTP request object associated as a property of the HTTP context object. So you have HTTP request, which is an object attached to the main request processing object, which is HTTP context. All right. So this is typically what happens when you go to your browser and issue a request. And that what's happened in ASP. If your application is the web application serving or managing your request response analogy is an ASP.NET Core implemented web application, this is what happens. So you have this HTTP request object mapped to the typical properties that are associated with a request from the browser. And for instance, you have Thompson coding series, which will map to the path, the authority, everything here. The scheme will be mapped to the properties of a typical HTTP request object as represented in the .NET platform. And you would make use of middlewares such as routing and endpoint middlewares to process such requests. And if you look at, we have routing and endpoint middleware. These are middlewares that associate request path to their respective request handlers. So for instance, we have app.mapGet, which is a GET request, and you see this here is the default path in this application. And the value is just return welcome to ASP.NET Core. I'm a typical HTTP response. And this is the path. And ideally, you will notice that this path here, which is which is underlined by the orange shade, also is a property in the HTTP request object, which also is represented as a property in your browser request. So you can see this is underlined here, and this is also here. So that is to show you, okay, how we utilize the different parts of a request in processing responses. All right. And the next thing we will consider is the request pipeline in a typical ASP.NET project template. So basically, you have a request, and the request passes through this pipeline. And these pipelines, these middlewares are pre-configured middlewares. Pre-configured means they are already configured on your behalf by the ASP.NET Core project, depending on the project template you choose. And the request passes through the exception handler middleware, the HSTS middleware, the HTTPS redirection middleware. So the blue components here are actually middlewares. All right, so your request travels through this to a particular endpoint. All right, and most times you may say, Dominic, what do you mean by endpoints? That's why I said it is vital for you to listen to the Web Development Fundamentals series. It will give you a good knowledge about the functions, the terminologies that are associated with web application development. Typically, you may have your project, your ASP.NET project could be an MVC project template, or could be a Razor project template. And based on the project template, they are pre-configured middlewares. So for instance, you notice that there are more middlewares in the MVC pipeline than in the Razor pipeline. You have the resource filters, model binding middleware, model validation middleware, action filters, and exception filters, resolve filters, and your custom code in the MVC middleware, or MVC pipeline, as the case may be. And in the Razor pipeline, you have the same thing, and you have page filters and user code, which is the code you have. And it is also possible for you to write your own custom middlewares and inject them into this pipeline where necessary. So typically, when your request hits the user code, as the case may be, it actually generates a response, as the case may be. The response travels back to through the endpoint and goes through all these middlewares, and the response goes through the exception and generates a response for the user, which is sent through Kestrel back to the user agent. So typically, this is ASP.NET request processing pipeline. I would advise you go deep into it a little bit to understand what each of these middleware they actually perform in the pipeline. So for instance, the static files middleware allow you to inject static resources such as HTML documents, JavaScript cascading style sheet documents into the pipeline that the web application can actually utilize. And user authentication middleware is used to authenticate users who have access to this web application. The authorization checks the credentials of the users to ensure that they're actually authorized to do whatsoever request they require the web application to process. And that is typically what we do. The endpoint middleware resolves which point in the request pipeline, or which endpoint does the request is intended for, which was the target endpoint for that request. So this is a vital knowledge for you to comprehend. You need to understand this in developing ASP.NET Core applications. So the next thing we would consider is more of the internals. And ASP.NET Core is fundamentally a console application. I've already said that, and it's wired with configurations that transforms it into a web request processing engine. These configurations transform it into the full-fledged web application that defines all the functionalities it is set to offer. So like a typical .NET 6 console application, it starts with the program.cs file. And this file will define and use the web application class in the ASP.NET Core library to bootstrap our web application. The web application class is pre-configured with basic required middlewares. Don't forget that, to power the kind of web application you intend to develop. These pre-configurations are made based on the project templates you choose to work with. This details is very vital for your understanding when working with or building web applications or engaging in web projects that are dependent on ASP.NET Core. In addition, we can inject additional service configuration and middleware components to satisfy the requirements of our applications. So we have an application, a typical web application, we have pre-configured services, and we have service configuration that is configured using dependency injection. And we have middleware components, app requests. The middleware components are the app request handling pipeline definitions. And we have this. So what are the three fundamental drivers that are necessary for a typical ASP.NET Core web application? So the very first thing I want you to understand is the number one driver is configuration. Configurations concern services and functionalities that the web applications you're developing requires. All right, so you need to configure them. These configurations basically are settings. The settings you do on your web application. Routing is a very vital component. It refers to endpoints that will be responsible for managing requests, because when you're sending a request, each request has a path, and the path is actually the endpoint where it wants to talk to in an application. So endpoint routing is very necessary because almost all web frameworks have to do with these three components: configurations, routing, and host. And the routing is the path that you're doing. So for instance, you want /document, /video, all these endpoints are actually the points you're interacting with the application. And host is what manages the lifecycle of the application itself, what is responsible for turning down the application and restarting the application if the system automatically shuts down and restarts, what really automatically starts this application. So these are the three fundamental things you need to be aware of in your typical ASP.NET Web Core application. Let's evaluate the ASP.NET Core Minimal API project template and see what that has. So we have a var builder which creates a builder, and we have a bunch of services called, and we have build, we check the environment, and we map it to an endpoint and run the application, and basically it bootstraps and starts a web application on the fly. And let's go into more details about what this code on the screen actually means. So we have this representation here now. So the very first line of code that we've seen has the var builder is equals to web application or create builder creates a new instance of a web application builder. Remember, web application builder, not the web application itself. So you use the builder and configure your services. So with the builder, we can do the second line of instruction is a pre-configured DI container. We use the pre-configured DI container to add the specified services we want for applications. So this code is actually the default bootstrapped code by ASP.NET Core Minimal API project. And what actually creates the web application class itself is the builder.build. So the builder.build here returns this line of code, builds and returns a configured web application. So first we have a web application builder. We use it and configure the web application with the pre-configured DI container, and we build the web application. When we call the build method, this actually creates a pre-configured web application. All right. And this is traditional to almost all the projects we have in ASP.NET Core. And based on the applications now, we have this application as an app here. And we check this line of instructions, checks which environment we are. And based on the environment, we inject this middleware. These are actually middleware components. in .NET, when you see use this or use Swagger UI, these are actually injected middlewares. You're passing middlewares into the pipeline. So you're saying if this is a development environment, make sure you inject the Swagger middleware and the Swagger UI middleware. And we also use HTTPS redirection, including this is another middleware, and this middleware actually runs irrespective of the environment. That is typically what it means. So we configure a middleware component for the web application referenced by the app variable. Okay. And summaries are just, this summary is just a resource, just simple, typical data, an array, nothing more. Yeah, and this is actually a more vital aspect. So this is actually an endpoint, all right, where I tell you about routing. And for instance, this is the configuration, and which I actually specified, and this is the routing, all right, when I said the three most important drivers of ASP.NET web application. So this has to do with configurations, and this has to be with the routing. So here typically we have the app.mapGet, which tells the host that this is a GET request, but the endpoint here is weather forecast. That's why we have this endpoint. So this configures a URL endpoint for the web application. The with methods assigns the name to the endpoint. This is for OpenAPI specification, because add SwaggerGen and use Swagger UI are actually OpenAPI specifications for RESTful services that gives documentation for RESTful services. And sorry about that, that is a mistake. Let's go back one more time. Let me go back there. All right, we're back here. So we have the endpoint specifies the type of HTTP method and the handling logic for processing a request on this endpoint. All right, so we have an endpoint and we have a request processing logic for that endpoint. And the signature for the endpoint is fairly simple. It takes a path and a delegate handler. All right, so remember when I said that the request pipeline in ASP.NET Core makes use of a request delegate, and that is what. So this Lambda expression here is actually a request delegate. All right, and that is what we mean by that. And this returns a forecast, and this instantiates the data, just performs a little bit of logic, and returns a result whenever this endpoint is actually called. This endpoint is actually a path. So whenever we call this path, this is what the response we get from the application. All right. And when this happens, we have app.run. App.run runs the web application on a default port. And this makes applications live. So it runs it on the server. And when you hit the open the browser and issue a request, the app run, and the request that runs the web application on the web server, and that makes it function. And we have a live running web application. So we will go into, if you do not understand it at this point, I'm going to do a brief demo, and you will have adequate understanding about all this when we are doing the demonstration of these concepts. And let's talk a little bit more about the web application class. It is very vital for your understanding. All right, so what are the internals of the web application class? It's vital for you to understand this as well. So this class is used to configure the HTTP request processing pipelines and routes, and it implements, or what we mean when we say implements, it derives or implements the following contract specifications. An iApplication builder. This is a contract specification that defines application request pipeline configurations. All right, that is the HTTP class implements that application builder. It implements the endpoint route builder, which contains specification for applications routes building and configurations. It contains an iHost, implements an iHost specification that manages the starts and stops of an application, and it implements an iSync disposable, which contains contract specifications that provide mechanisms for an asynchronous release of unmanaged resources. And we have the iDisposable, which contains specifications that provide mechanisms for release of unmanaged resources. iSync disposable actually is an asynchronous way of doing that. iDisposable is a synchronous way of releasing unmanaged resources. And it has the following properties, which is very vital: configuration and applications runtime configurations, environment and applications in runtime environment, lifetime events notification services, a logger and application defaults logger, services, configured services for the application, and URLs, a list of URLs that the HTTP server is bound to. And in addition to these, it has a bunch of methods and extension methods for a variety of purposes. So this information, for more on that, you can get this information about this ASP.NET Web Application Class using the link on the screen below. All right, and let's delve into